Review Prep podcast. In this series, we go through topics that are discussed in data science interviews and we give a high-level overview on those subjects. In today's episode, we'll be discussing Word2Vec, which is important to understand in the field of natural language processing, which I will refer to as NLP for the rest of this episode. So let's start with a high-level overview of Word2Vec. Word2Vec is a neural network-based method that allows us to represent words as numerical vectors in a high-dimensional space. Now, it's a popular tool used in NLP because it allows us to capture the meaning of words and their relationship with other words. So in this episode, we will discuss the technical knowledge behind Word2Vec and also try to give some analogies wherever possible because, as you might know by now, I do love analogies. So first, let's dive into the basic idea behind Word2Vec. So the principle or quote-unquote theory, so to speak, underlying this method is this idea that words appearing in similar contexts are likely to have similar meanings. For example, if the words school and student often appear together in sentences about education, they might be considered similar in some way, right? This logic makes sense to us. If a set of words are often found together, we might assume that they share some sort of relationship. So for instance, you might associate summer with the sun and heat, so these words might trigger some sort of contextual understanding for you. For a machine to understand language, we need to somehow represent these words numerically, and we need to also somehow try to capture the relationships numerically. So Word2Vec helps us with that problem since it takes this idea of words and context and turns it into this mathematical framework for representing words. And Word2Vec is based on a neural network architecture that's called the feed-forward neural network. And if you aren't sure what a feed-forward neural network is, well, it's basically a neural network where the information flows only in one direction, from the input layer through one or more hidden layers to some output layer. And each layer of the network is made up of neurons that perform some mathematical operation on the inputs and pass the result on to the next layer. So in the case of Word2Vec, each neuron in the input layer represents a word in the vocabulary, and each neuron in the output layer also represents a word in the vocabulary. And the hidden layer is actually where the word vectors are generated. So the weights of the connections between the input layer and the hidden layer, and between the hidden layer and the output layer, determine the vector representations of the words. So during training, these weights are updated to minimize the difference between the predicted and actual context words or target words, depending on whether you are using the continuous bag of words, SIBO, or skipgram architecture. And if SIBO or skipgram sound new to you, let's take a moment to briefly explain these two concepts. So Word2Vec uses a neural network with one hidden layer to train these word embeddings, right? Well, there are two main methods for training Word2Vec, the SIBO and the skipgram. So SIBO works by predicting a target word based on its surrounding context words. In this case, the context words are used as input into the neural network and the target word is the output. Our model then tries to minimize the difference between the predicted target word and the actual target word in training. So for an example, take the sentence, "The cat sat on the mat." The context words for the target word sat could be the, cat, on, and mat. So the SIBO model would take these context words as input and try to predict the target word sat. So in this case, with SIBO, we are using the context words to try and predict the target word. Okay, so on to skipgram. Skipgram is essentially the opposite of SIBO, or it works kind of essentially in the opposite way of SIBO. So skipgram predicts the surrounding context words based on a target word. The target word is used as input to the neural network, and the context words are the outputs. So for example, if we take the same sentence, "The cat sat on the mat," the target would be sat, and the context words would be the, cat, on, and mat. So the skipgram model would take the target word sat as input and try to predict those context words, the, cat, on, and mat. So here we're really doing the reverse of the SIBO, because we are trying to use the target word to predict the surrounding context words. So you might be wondering which one is better to use, but honestly, SIBO and skipgram both have their advantages and disadvantages, so it depends on your use case. SIBO is faster and works better for frequent words, but skipgram works better for infrequent words and captures more fine-grained semantic relationships between the words. So again, the approach that's better depends on your use case. Okay, and so moving on, the word vectors generated by Word2Vec also have some interesting properties. Firstly, they can actually capture the syntactic and semantic relationships between words. So let's take a famous example, for instance. If we take the vector for king and subtract the vector for man and the vector for woman, we get a vector that is closest to the vector for queen. Now, this shows that the model has learned something about the relationships between words, and researchers noticed that words that are similar in meaning tend to be clustered together in this high-dimensional space. It's also good as well to try and visualize what's happening with Word2Vec, and one way to think about the word vectors generated is that they are kind of like coordinates in a high-dimensional space. So each dimension represents a different aspect of the meaning of the word, and the combination of all the dimensions determines the overall meaning of that word. So we can try to understand Word2Vec through an analogy. Now, these analogies might not be perfect examples, but I hope they give some conceptual clarity on how Word2Vec kind of works. So you can think about Word2Vec as a tool for compressing language. Just like a JPEG file compresses an image by throwing away some of the less important details, Word2Vec compresses languages by reducing each word to a high-dimensional vector. And as it turns out, this compression is useful for many NLP tasks like language processing and translation and text classification. Okay, so to kind of wrap up what we've discussed today, we've learned that Word2Vec is a neural network-based method for representing words as high-dimensional vectors, and it works by using either the SIBO or skipgram approach, which allows us to capture the relationships between words. And the resulting word vectors can be kind of thought of as coordinates in a high-dimensional space or as a form of compression. So that about wraps it up for today's discussion on Word2Vec. Thanks for tuning in to today's episode of the Data Science Interview Prep Podcast. We hope you found this episode helpful and informative. Be sure to join us next week where we will discuss other interesting topics in the field of data science. Until then, happy modeling!